Chapter 4 Programming. It's now or never. Now that you have been introduced to variables and how to assign data to them, you can best begin to program. Through output and input statements, your program will allow a user to interact with the program. You'll learn the basic elements of any C++ program, namely the main section, the return statement, and the input and output statements, cout and cin. Statements like cout and cin allow you to display and retrieve data within a program. In this chapter, review of declaration and assignment, writing an output statement, understanding the cout stream, the endl command, how to insert comments into a program, introduction of compiler directives, the main section of a program, the return statement, 3 short programs. Putting a program together. We are almost ready to write some short programs. In the past 2 chapters, we have looked at some of the initial aspects of programming, namely declaring and assigning the variables and manipulating those variables through operators. Throughout this chapter and the following ones, we will use the C++ programming language commands. Declare, assign, and manipulate. If you recall, when declaring a variable, we tell the computer that a variable is of a certain type so that the computer can set aside the appropriate amount of memory. In C++, the word for integer is shortened to int. Let's declare 2 integer variables as follows: int first val, second val. Now we have told the computer that 2 variables called first val and second val will be used in our program. We have just declared the variables, that is, introduced them to the computer. The next step is to assign the variables. We will let the programmer assign the first val variable. Let's leave the second val alone for now. The following statement will accomplish first val's assignment. First val is equal to 25. The third part of this process involves using one of our operators from chapter 3. We will use an arithmetic operator and the multiplication sign. Here we will also use the second variable to hold twice the contents of first val's value. Second val is equal to 2 times first val. This means that second val has the value of 50 because 2 times first val, 25, is 50. Time for an output statement. In our next stage of writing a program, we should show the contents of second val on the screen so that our user will know we doubled the value of first val and produce second val as a result. We want the user to be able to see his output, the data that the computer has generated through the manipulations we performed. An output statement is a programming language statement that generates output, data contained within variables or messages to the user to be directed to the screen. An output statement in C++ will have 3 key parts: a stream name, an insertion operator, and a variable or message. The stream name is the name of a channel where data is sent before it goes on to the screen. An insertion operator is an operator that inserts data into that stream. After the insertion operator, either a variable or a message can be placed. The variable's value will be inserted into the stream and then shown on the screen. Because C++ is a high-level language, you do not have to worry about how the stream sends its data to the screen. That does not concern us. We just need to ensure that we are sending all data and messages properly to the stream. Cout. Cout, pronounced cout, is the name of the stream where data gets sent before it is channeled to the screen. This stream is the opposite of the cin stream introduced in Chapter 3. When you use a cout statement, you are really sending data to the screen through the cout channel. Anything that is sent to this stream will eventually end up on the screen, where it can be viewed. The syntax for using the cout stream goes as follows. You name the stream cout, then you follow it with the insertion operator symbol, less than, that indicates something is going out into the stream. Next, you put the variable name or message that you wish sent to the screen via the stream. Messages must be in quotation marks. Let's look at some examples. Cout, first val. Cout, hello. In the first example, we are sending a variable to the stream, which feeds into the screen. That really means that the contents of the variable will appear on the screen. In the second example, a message is sent to the stream and will be displayed on the screen next to the number in first val. It will look like this. 25, hello. When you wish to put more than one item into the stream, you need to use the insertion operator before each item. Let's look at some other examples where we use the cout streams. In both examples that follow, more than one item is sent to the stream, so the insertion operator is placed in front of each variable or message. Cout. Here is the first value, first val. Produces, here is the first value, 25. And cout, first value, second val, produces 25, 50. In our third set of examples, let's say you wish to use a period to finish a sentence that included a variable. You would need to use the insertion operator between the variable and the period, because the period is a string following a variable. Cout. The contents of second val is second val, period. Caution. Any output should follow the cout command and the insertion operator. If there is more than one item of output, i.e. multiple variables or messages, put the insertion operator before each item. Now let's say that you were using the string type mentioned in chapters 2. Recall that a string can hold several characters or words. The string type could hold a message if you assign the message to the string. Let's declare and assign a message to a string type. String, my message. My message equals have a nice day. Now we can send the message to the stream without using any quotation marks, because we will use the variable my message to hold the sentence. Cout my message. Tip: remember that variables do not need quotation marks. It is assumed that when a variable is sent to the cout stream, its value will be sent to the stress stream and ultimately to the screen. How to execute a line feed endl. The endl, pronounced end line, command in C++ causes a line feed on the screen. In order to have data and messages appear on separate lines, you need to direct a line feed to the screen. The way to do this in C++ is to put the end line command into the cout stream. When the data flows from the stream onto the screen, the endl command, end line command, will cause a line feed so that anything that follows this command will be on a new line. It is very important to notice that if end line is used at the end of a cout statement, the next cout statement will show data on the next line. Let's look at some examples with and without the end line command. Cout, first val. Cout, goodbye. Screen output, 25, goodbye. Cout, first val, end line. Cout, goodbye. Screen output, 25, another line, goodbye. Cout, hello, end line, goodbye. Screen output, hello, end line, goodbye. Notice that there were two line feeds though, so that goodbye is on the line after the next line. Comments. Another useful tool in programming language is the ability to comment. Another useful tool in programming language is the ability to comment in a program or put descriptive remarks next to a programming statement or statements. The reason for putting comments into a program is to make the code clearer for any reader of the program. As programs become more complex, it is useful to clarify what a section of a program does so that you or another programmer can go back to the program to make changes. Look at this example in everyday life. Sentence: Jack will be late today. Comment: Jack is the man who used to work with Mary. Programming statement. First value is equal to 25. Comment // first value is the original number of people who wanted tickets. Notice the symbol / used to the left of the comment. When you write a comment for a program, you do not want the compiler to think that your comment is part of the code that is being executed. Before every comment you write, the symbol, the / tells the compiler to ignore what follows on that line. Recall that the compiler is the translator of your code. It tries to make sense of every command you give it. So the symbol / is a way of telling the compiler not to translate what follows. If your comment is longer than one line, you need to use two different symbols, one to indicate the beginning of a block to be ignored, the / multiplication, and then another to indicate the end of the block, multiplication sign, division sign. These symbols function like parentheses. After the second symbol is read, the compiler knows it can start executing code again. Division, multiplication. Everything to the right of these symbols is ignored. Write whatever you want in here, since this code will be ignored. The end of the block is to the right. Multiplication, division. Compiler directives. Now that we have seen 4 parts of early programs writing, declaring variables, assigning them, manipulating their values, and displaying output, what else does a program need? Compiler directives sounds like a complicated term, but it is not. The first thing is to recall what the compiler does. The compiler translates high-level language code into low-level language code, and ultimately machine language code that the computer understands. A directive is just a fancy word for direction. So compiler directives are special directions for the compiler. Although there might be several compiler directives, we are only interested in the specific directive, the include directive. The include directive. The include directive is a special instruction in C++ for the compiler to get a specific file that we ask for and insert it at the top of our program. That way, our program can benefit from any of the capabilities that the included file offers. When the compiler starts to translate our program into low-level code, it first gets the file that was mentioned at the top of the program and starts to translate that code. Whatever that file can do, our program can now benefit from it. There are several files that we might like to use in any program that we write in C++. The files that have names that all end in the extension .h, which stands for the classification of a header file. An extension is an appendage used to indicate what type of file you have. You may have seen other extensions that are attached to file names like .jpg and .gif, which refer to files that made up of pictures. A header file is a file that can be placed at the top of a program and accomplishes certain tasks that the file including it needs. Later in chapter 16, I will discuss header files in more depth. Here are some examples of header files we might like to use at some point in our programming. Header file name, description. iostream.h manages the streams used for input and output of data. String.h manages the string type variable. Math.h allows many math functions to be performed on data, similar to those on a calculator, such as sin x, abs x, and so on. If you recall, input is necessary when someone other than the programmer wishes to load data onto variables. That is, the user wishes to send values into variables. Output, or sending data to the screen, is a basic aspect of most programs. There are very few programs that would not send some results to the screen to be viewed. For these reasons, practically all programs need access to the streams that channel data to and from the keyboard and screen. The iostream.h, pronounced iostream.h, file allows us to use both the cout stream for displaying output on the screen and the cin stream from chapter 2, which allows the user to assign variables through keyboard input. These two streams are part of this file. At the top of our program, written C++, we must give the compiler directive to get iostream.h. The directive looks like this: $include iostream.h. The number symbol $ indicates that this is a directive to the compiler iostream.h. iostream.h is the name of the file that manages input and output. In the appendix on C++, Appendix B, you will learn more about these header files. Tip: we will put $include iostream.h at the top of every program we write in C++ because we always expect to have input and output in our programs. the main section of a program. Programs are broken into sections. At the top of a program are any files that might help our program accomplish its task. After that, a program can be broken into sections where each section accomplishes a specific task. The reason for the subsections is really one of organization. By blocking code into separate sections, you are organizing the code so that any reader can understand it or fix it if necessary. This is especially important if there are errors in the language code. The main section. The main section contains the body of a program. With the first program we write, it is not necessary for us to move away from the main to other subsections. All the code that we write to execute some task will be contained in this main section. Later we will learn how to compartmentalize a large program, that is, break it into sections that each do some task rather than having all the code in the main. The main section has a heading, like a title, and is followed by two braces, an opening brace and a closing brace, to indicate where the main section both begins and ends. Inside the braces go the programming statements that you write. int main, parentheses, / the heading of the main section, opening brace, the opening of the opening brace there. Your programming statements go between these braces. Return 0, semicolon, / the return statement, the closing brace, the closing brace. The heading, in the heading, you see the word for an integer, int, followed by the word main, and then some empty parentheses followed by the braces that begin and end the main section. In Chapter 8, I will explain the syntax of this heading. Just use it for now. The return statement. The return statement is the last statement of the main section, and you might consider the return statement in the following way. Imagine that the compiler has been given a key to the main room, the control room of the program. This room is usually locked because it is the control center and we don't want to just anyone going in there. When the compiler is done with the main section, it returns to the key to the room for security reasons. This key is an integer according to the first word in the heading of the main. The compiler is being directed to return an integer before it leaves the main section. Since many programs don't necessarily produce an integer, we come up with the idea of returning the integer 0 as a matter of simplicity by using the return 0 command at the bottom of the main section, the programmer is satisfying the compiler's requirement to generate an integer before leaving the main section and closing the program for good. Once it does that, the program is over and the compiler's work is finished. In Chapter 8, we will learn more about how this statement works, but for now, this explanation should suffice. int main open brace. Your programming statements go between these braces. Return 0, closing brace. The heading gives some information about the main must finalize. The heading gives some information about how the main must function. An integer must be produced before we can close the main. The last command, return 0, allows the compiler to leave the main section carrying the integer 0 and know that it has finished its work there. We are now ready to build an outline of a program. Building a program outline. We are now ready to build an outline of a program. The first part of the program should include any directives to the compiler. The next part will be the main section, blocked off by the opening and closing braces. So now our outline looks like this. #include iostream.h int main parentheses opening brace / your programming statements int main parentheses opening int main the heading. Your programming statement go between these braces. Return 0, returning an integer so that we can satisfy the heading's requirement of an integer being produced, closing brace. Now let's look at some of the code programming statements talked about previously. I mentioned that it was necessary to include the declaration of a variable. The program outline can be completed in this way. #include iostream.h int main braces opening brace int first val second val the declaration section return 0 closing brace. Now we can insert the code that causes assignment of values to variables. #include iostream.h int main opening brace int first val second val first val equals 25, second val equals 2 times first val. The second val assigned twice first val's value, return 0 closing brace. In the next example, we include the output statement. #include iostream.h int main opening brace int first val second val / the declaration section. First val equals 25, second val equals 2 times first val. Second val assigned with twice first val's value. Cout. Second val end L, semicolon. Second val's value is printed. Return 0, semicolon. Execution of the main section will now end. Closed brace. Some short programs. Now that we have examined the outline of a program, we are ready to see some sample programs. In each program we write, look at the basic structure of the program and keep in mind that it will probably contain 3 or 4 elements. 1. Declaration of variables. 2. Assignment of variables. 3. Manipulation of those variables. 4. Variables values printed on this screen. Example 1. A program that computes the average of 3 numbers. Description. We will declare 3 variables to hold 3 distinct real numbers assigned by the programmer, and then we will compute the average of those numbers and display it on the screen. In addition to declaring 3 doubles to hold 3 real non-integer numbers, we need to declare a variable to hold the average. We'll call that variable average. Notice the use of the 2 arithmetic operators, addition and division, to compute the average. Since we are using doubles, non-integers, with the division symbol, it will perform division just as a calculator would by displaying the remainder in decimal form. After examining the code in the following program, look at the output produced if the program is run on a computer. Recall that output is anything displayed on the screen, the data values that the variables contain after those variables have been manipulated. The program. # include iostream.h, int main opening brace, double first val, second val, third val, average, declaration section. First val equals 25. Programmer has assigned all. Second val equals 38.9. 3 variables. Third val equals 42.7. Average equals first val plus second val plus third val divided by 3. See out. The average of the 3 numbers is average. Period and line. Note how this line wrap to the next line. Return 0, closing brace. The output. The average of the 3 numbers is 35.53. Example 2. A program that computes the average of 3 numbers from the user. Description. Let's take that same program and let the user assign the variables. Remember that we should ask the user first for the values so that he will understand what to do. The program. # include iostream. Int main opening brace. Double first val, second val, third val, average, declaration section. See out. Please type 3 numbers, end line. See in. First val, second val, third val, the user. assigning variables by typing numbers at the keyboard. Average equals first vowel plus second vowel plus third vowel divided by 3. Cout is the average of the three numbers is average. Period, end line. / Know how this line wrapped to the next line. Return 0, closing brace. The output. Please type the three numbers 25, 38.9, 42.7. The average of the three numbers is 35.53. Of course, the value shown will depend on what the user types. Example 3. A program that prints the user's name on the screen. Description. In this third example, we will ask the user for his name and store that value in a string. Then we will display the string's value on the screen. The program. # include iostream, # include string.h. Here is the second directive to the compiler. Int main, opening brace, using namespace std. String name, declaration section. Cout, what is your name? End line. Cin, name, user assigns value by typing it at the keyboard. Cout, your name is name, period. Return 0, closing brace. The outcome, the output. What is your name? Jack. Your name is Jack. What is your name? Jack. Your name is Jack. Example 4. A program that updates a checking account balance by recording an amount as a debit, something to be deducted from an account balance. Description. In the fourth example, let's ask the user for the amount he wishes to subtract from his checking account balance. In the fourth example, let's ask the user for the amount he wishes to subtract from his checking account balance. Then we will subtract that amount and display the new balance. The program. # include iostream. int main, opening brace. Double balance amount declaration secret. Cout, what is your balance? End line. Cin, balance. Cout, what is the amount of your check? Cin, amount. Balance equals balance minus amount. Cout, your balance is now balance, period, end line. Return 0, closing brace. The output. What is your balance? 345.67. What is the amount of your check? 26.75. Your balance is now 318.92. Although these programs are limited in what they do, they give you an idea of how a program is structured. You need to remember that all variables should be declared prior to use, then assigned by the programmer or by the user. After that, you can manipulate the variables and display output. In Chapter 6, you will learn to make decisions on the computer. This will allow you to write a lot more interesting programs. Some examples of programs that involve decisions would be choosing the largest of a group of numbers, or giving the user a choice in responding to a menu of choices. None of these possibilities could be accomplished without some sort of decision-making ability in a programming language. On the CD. The 4 programs in this chapter are written in Java, so you can see the difference between Java and C++. Summary. In this chapter, we looked at the essential elements of a program: declaration, assignment, and manipulation. To be really effective, most programs will display then results on the screen. What is displayed on the screen is known as output. The use of the cout stream and the insertion operator allows us to produce output. The endl command allows us to execute line feeds on the screen. Another good feature of clear programming is the careful use of comments. Comments can be used to explain the purpose of programming statements to any reader of a program. When you comment a program, you need to use some symbol so that the compiler knows it is not executing a command. In C++, this symbol is the one-line comment symbol, or for multiple line comments, the symbol division multiplication and multiplication division to begin and end the section. Before writing a program in C++, we need to learn a few useful parts that comprise all C++ programs. The first is to include a directive to the compiler regarding input and output. In order to be able to display messages on the screen or get data from the user, you need to include the iostream.h header file. This file allows you to display messages and take in data. Another part of all C++ programs is the main section. The main is the body of the program. The heading of the main requires that an integer be generated before the main section is completed. Opening and closing braces show us where the main begins and ends. Once the main has been completely executed, the statement return 0 causes the compiler to exit the main properly, thereby ending the program. In the last part of the chapter, these are some of the examples in the last part of the chapter, these are some examples tying all of these elements together into 4 programs. In the next chapter, we will learn how to design a program so that it is well organized and easy to follow what tasks are being done.